Welcome to the Data Architecture Elevator podcast. Created by Agile Lab, we will explore the dynamic intersection of technology, innovation, and practices in the data space. Our company purpose is to elevate the data management game of companies that want to be data-driven, and this is the goal of this podcast too. For more information and insights, visit our website at www.agilelab.it and feel free to reach out our architects on LinkedIn with your question. Now let's step into the elevator with Agile Lab data architects.
Hello and welcome to episode 7 of Data Architecture Elevator. Today we cannot avoid talking about Agentic AI. It's a must nowadays, so we need to do it. With me today we have Antonino Ingargiola, AI architect, and Antonio Murgia, data architect. So we will see how this Agentic AI is impacting both on AI and data side. So what is Agentic AI? Agentic AI refers to artificial intelligence systems that have agency and can behave and act autonomously, make decisions, and execute tasks with a specific business goal in mind. And this autonomy typically involves the ability of sense the context and behave according with the actual context. So can really create dynamic path towards the solution of a specific task. And the key characteristic of an agentic AI system are, as I said, agency, so the possibility to take decision autonomously, to be goal-oriented, so moving towards the completeness, the completion of a task, and adaptability. So it's not a predefined workflow, but is a dynamic path creators. So maybe Antonino, can you describe in further details what is Agentic AI? But more important, we have seen also with the data mesh and data product story how important it is to better define and describe and use the proper words to describe phenomena. So I would like from you a definition of what is an agent, because nowadays it seems that everything is moving is an agent. So I would like to demystify this as first stuff.
Yes, thank you. So it's true. Agentic AI is in everyone mouth today, and it's a very broad term. That the term agent existed for a long time, and now it gained new meaning with the advent of LLMs and VLMs. So I would say that a good definition also introduced by Anthropic recently is considering an agent, an agentic system, a software system that use foundational models that can take decision in a workflow. So this decision degree can be varying from a decision between a few options up to deciding the whole workflow autonomously. And typically, these are LLM, VLMs that process unstructured data as input, so text, video, audio also, and then can act on this input. So typically they have tools to call, and the agent can decide which tool to call. Tools are, we can think of a tool as a function. So you can make it a tool to do anything you can do with software. A tool can be also another agent. And another aspect is the memory. Typically, whatever the agent knows is provided in the LLM context window. So the memory, the context, or the state of the system is encoded as a memory and should be managed. But this provides a very powerful pattern for solving a wide variety of tasks.
Clear. So making concrete examples, if I have something that is extracting information from a PDF, is an agent or a tool?
I would say that if you have a tool that gets a PDF and directly extract text from it, I will not call it an agent because it doesn't have much of an agency. But if it involves a more complex workflow where there are different paths that are taken depending on the type of the input document, it can very well become an agent.
So if we have the email writer agent, instead it could be an agent because you have to decide who is the distribution list, what kind of attachments you want to put into the email. And so there are so many decisions that are not prescribed and not defined in the workflow, so that this one has agency, so can be considered an agent.
Absolutely.
Instead, if you are doing an action that has no agency inside, even if is involving LLM or other artificial intelligence mechanism, it can be only considered a tool.
Right.
Good. Maybe Antonio, how can agentic AI be leveraged to improve business processes and create new revenue streams? So, in which areas you are observing customer implementing and looking forward to implement this agentic AI? I know we have a set of MVP undergoing in Agile Lab. So, in which area they are coming?
Well, the first area that comes to my mind is operational efficiency and also business process automation, which are usually tied together. So with agentic AI, we can try to take automation to a new level, because we can plug in dynamic decision making. So up to now, business process automation was about coding workflows that could be as complicated, as complex as you want, but upfront you need to code the workflow. While with agentic AI, we can start to do dynamic decision making. So it's the system itself that reason about the needs and its goal, and act on that without having a predefined and therefore probably obvious ways of acting. So a business process automation is usually, I don't know, stock is going down for a given item. You go and buy new items and put them in the warehouse. That's an obvious one that you don't need to be a business expert to let's say imagine that and implement that as a business process automation. While there are a lot of other workflows that probably come into the mind of a business expert, but they don't have the ability to code into a workflow and automate that. And an agentic AI can help into that, because it can be both the business expert to some degree, and also actually act on that, so automate those. Another interesting thing is adapting workflows into case by case. So it's tending toward the personalization also area, where in fact agents can change their workflow based on the context. Something that obviously predefined workflows cannot do, because you cannot cover all the different ideas and options. Still in the process, business process automation and operational efficiency. We have risk management, where agents and agentic AI can help humans into performing regulatory compliance tasks, can help also in, let's say, more traditional cases like predictive maintenance or fraud detection, for example. And I think that's all that comes to my mind about operational efficiency. And then we have also the part on product personalization and innovation. So an agent, as let's say a human agent, also an AI agent can do dynamic personalization based on the context, on the customer, on his history. So they can tailor product recommendation, pricing, using experience, all of that dynamically based on the context and on the user. And this can be done at a scale that humans cannot do. You would need too many human agents to do the same scale of personalization. And well, finally, something I didn't that just came to my mind that I didn't touch in the first point. So about operational efficiency is customer care. You can offer customer support 24/7, because you don't need people to be there all the time. And these agents, each agent could be tuned for a given product of your portfolio. Imagine you're an insurance and you sell insurance products on different products. Let's say car insurance, house insurance, whatever, health insurance. You can have different agents that are experts on a given product, and then through Agentic you can decide based on the customer and what he's asking for, drive the conversation to the agent that an expert on that product line. And in this way you can give better answer, faster answer. You don't need a human in the loop, and this obviously save money in the long term. On this side, given the agentic nature of agentic AI, you can also mix in other traits that are hard instead to have in a single person or human. For example, you could mix customer support with upselling and cross-selling. Usually someone in the customer support doesn't try to sell you new products, but agentic AI can move the conversation to the right agent that is also a salesman, let's say. So could help you sell more products.
Nice. From a data architect standpoint, which are the key considerations in order to deploy and put in production this agentic AI, because we know agentic AI are taking decision on top of data. So which are the precondition or the key consideration in order to enable this?
Yeah,
And
so
what you're worried about?
we probably end up, in Italian you say, sounding like a broken disc. So you always repeat the same stuff. But again, data is the foundation of Gen AI and therefore agentic AI. So you need to have a strong data foundation. You cannot risk to have bad quality data fed into the fine tuning, the training, or even the context of an LLM or an agent. So while when a human looks at a BI report, can understand data quality issues, an LLM or an agent is very difficult that will be able to do the same as of now, for sure. So again, data quality is even more important than in the past. Also, to support agents, one very efficient and effective pattern, let's say, is retrieval augmented generation. And therefore, as a data architect, you need to design the retrieval augmented, let's say, the retrieval mechanism that usually sits on top of a vector database that keep and store and allow to search for semantic embeddings, so that the agent can first search into this vector database based on the prompt or based on his tasks, let's say, recover and retrieve important information about what has been asked, and then embed this information in its context. This helps create and have better results, because you are feeding some more information that might not be in the training set of the foundational model, and also can be useful because the source can be attached to the output. So human users can also, if they want, check and avoid hallucination, or let's say be their own guardrail. And to overcome limitation of vector databases and semantic embeddings, because they don't understand concepts, they just go for similarity in the prompt, in the input. You can do one more step that right now is at the forefront of research, that is incorporating business ontologies. So if you build your domain-specific ontology, you can bridge that gap between the foundational model and your domain and your business, because ontologies can link concepts, and so they go even further what vector database and semantic embedding can do. Another, let's say, architectural thing that we need to keep in mind when working with agentic systems is auditing and traceability, because given the fact that these agents are taking decisions, are generating workflows that are completely dynamic, at some point you need to log and easily, let's say, debug even after the fact, what decision were taken in which context, with which input, etc., etc. So it's very important to audit log all actions and all inputs and output that any agent actually took. Otherwise, you don't know what's happening, why it's happening. Well, why it's happening probably is going to be hard anyway, but at least you can try to replicate the same exact scenario and understand what's happening.
Yeah. It seems to me all of these are typical cross-cutting concern, but I believe these agents will be developed in the business and wired in the business process. So how can we take care of such cross-cutting business, cross-cutting concern, architectural concern? So how do we govern these agents from an IT standpoint?
So I can take this one. I think, again, you need a platform. As for a data platform, you need an agent platform, or call it as you want, because so agent will need descriptors, will need to be let's say in some way checked and audited with policies that are internal to your organization before going to production. And going to production for an agent means another agent can call this agent. So it's even more important to be in the position to be sure that the agent is doing the right thing for a given definition of right thing, because the problem can be decuplicated. It's not like you're deploying a feature, let's say, or a data set somewhere. Well, it's similar to a data set, because in the moment the data set is live, anyone can use it. And if there's something wrong with that data set, the error is going to spread across all your reports or whatever. The fact that this is even more dangerous is that another agent can pick that agent to work with. And given the speed on how this happens and the scale at how this happens, there are no humans in the loop. So if for any reason an agent is presenting itself in the platform as a very powerful one, whatever the definition of that is, other agents can always choose it to solve a task, to solve part of the problem. But if that agent has some problems and is generating incorrect results or weird workflows, the problem is going to spread very fast. And also the reason you need a platform is to actually enable this dynamic scenario where you discover agents at runtime, and you can always add or remove agents from your platform, and yeah, that's the reason why you need a platform. Another is to take care, again, of cross-cutting concern. So standards and policies like agents cannot do these kind of things. Agents should be tested. Agents interact with tools in this way, or agents interact with other agents in a given way. It can be a protocol, high-level protocol. You could enforce that communication is always structured and things like that. And you need a platform, otherwise it's going to be a mess, and they want to be able to talk with each other effectively.
This is a lesson we learn in data with data products, for example. So every time you want to decentralize the management of something in the business without losing control, without losing governance from an IT standpoint, you need to have a platform in between acting as a marketplace with specific rules. Okay, so and these platform should not only be a monitor one, but should enforce the life cycle, the end-to-end life cycle. Otherwise, you will never have control of this decentralization. So it's crucial to me starting to talk about agents, management platform, stuff like this. But very good. Antonino, if we want to start to develop an agentic system, we want to start architecting the software architecture of an agentic system. What kind of possibility do we have? Patterns, frameworks? How would you frame the overall software architecture of an agentic system?
Okay, of course, this is an extension of the problem of software architectures now using LLMs. For the single LLM, that is basically a model that was trained on a large portion of the internet, but is nonetheless very generic information, not specific to the business. The LLM is able to distill lots of information if prompted correctly. And correctly, I mean through some patterns that have been discovered. For example, React is one of these patterns, which you alternate between reasoning step and action step. It's a way to stimulate the LLM to think through when it's solving a task. Or another one is a chain of thoughts, in which the LLM itself generates a series of steps between tackling each step individually, or tree of thoughts, because we are going always towards a more search pattern in which you allow the LLM to generate many options and then search for the best option. For example, tree of thoughts is one of these, and the recent trend of reasoning LLM leverage heavily this pattern, like O1, O3, or the Queen and Queen model, and so on. But beyond the single LLM, that is one component of the system, you can compose different, let's say, agents in a whole system, agentic system, through patterns that are reminiscent of the microservice architecture. To make a parallel, you can have an orchestrator that orchestrates different microservices, and or a choreography architecture in which one microservice calls the other one. And in the agentic world, you can do the same essentially. And there are several patterns that are emerging, the architectural patterns that you can compose to build your application. So
there are a lot of similarities with the microservice world, right?
Yeah, there is a strong similarity, and I see it as an extension. Nowadays, not many frameworks don't use separate components implemented as separate microservices, but we are going more and more toward this pattern. Some tools are starting to implement it, because in enterprise world is more easy to govern, and we use also a set of governance tools that exist already to manage APIs, things like rate limits, quota, access control can be naturally be applied to this new landscape.
I know across different projects we are testing multiple frameworks. So we are testing LangGraph, Crew.ai, and Autogen. All of them are still monolithic in terms of software architecture, so there's no possibility to have remote agents and registering them. So I think it's because we are super early stage, and but this is a kind of evolution that I would like to see in order to deploy them in a large organization. So moving towards a microservice architecture. Do you have any preference among these three frameworks? Why there are specific characteristics that you take care of, or you value more than other in choosing a framework?
I don't have a specific preference, but I would say that a suggestion I can give is when choosing a framework is to pick one that does not hard code some patterns. For example, many agentic framework hard code the React step. So when you use an agent, is by default implementing the React series of steps, so reasoning, action. But it's better to have a more general purpose framework, so you can implement different approaches, since these are very fast evolving and you don't want to be linked to one specific one. And moreover, oftentimes these patterns are hidden inside the code. So unless you go and read the code how a single agent is implemented in this framework, you don't know exactly what's the logic inside. And it's very important to be aware of it.
Yeah, also internally, we didn't decide yet how to standardize this development. It's too early. So right now, the direction is to experiment as much as possible with all of this. And then I think naturally one of two of these frameworks will emerge in terms of adoption by the community. And at that point, it will be the moment of making a choice and standardize the way we operate with agents. But right now it's too early. I have seen also AWS as an open source agent framework. A lot of them are coming. Yeah.
Also, Microsoft has a semantic kernel that is the former framework that now is converging to Autogen. But still, we are still in the early days.
Yeah. Good. Last question. In order to implement or starting to implement agentic AI in a business environment, I think this year will be the year of MVP, where people will get more awareness about what is possible to do for real in a business context. So Antonio, which are the key concerns to take care of when we are planning to put an agentic AI in operations?
The first that comes to my mind is guardrails, because anytime you give autonomy to something, and we gave autonomy to domain teams. We gave. I would love to say we gave. We are trying to give autonomy to domain teams in data mesh and, let's say, domain-driven design and microservice architecture. And now we are giving or trying to give autonomy to foundational models, to agents that, let's say, can probably be trusted less than human beings. And therefore, we need guardrails in the same way we needed guardrails when we were decentralizing with human teams. So guardrails in the context of agentic AI means implementing strict boundaries on the parts that we let the agent perform decision making. So everything we know up front and we can easily code, we should code it and put it as a strong boundary so that the agent cannot go into that direction. We should probably also prioritize the application of agentic AI to areas that are not that critical legally or can actually harm people or the company itself, obviously. And one very easy way, let's say low-hanging fruit, is is implementing guardrails as part of tools, because a tool usually is something more deterministic than an agent, and therefore putting boundaries on it is much simpler. Is how we put boundaries on any code we write. And again,
to make an example, and to make it more concrete, so to avoid an agent exploiting information of another user, meanwhile talking with Antonino, basically the guardrail of what is possible to do is shifted into the tool. So the tool cannot return information of another user compared with the one you are talking with, and not delegated to the agent itself with the agency. Is it right?
Yeah. That's one way. Well, that's one good example. Another thing that no one is doing, like in software engineering, the same is here. We as humans are bored out of writing tests and evaluation suites, but I think given the nature of agents, testing is even more difficult, but even more important, because you have to test out the behavior and how the behavior changes with the changes you're performing to your model, to your agent. And performing changes to agents can be very subtle. For example, given that at some point in our vision, any agent can call any other agent for a given task that he sees fit. Even changing the description of an agent changes the chance that another agent will choose him for a given task. So even changing documentation about an agent can create a regression, or can create many problems in the agentic system, let's say. So we must be very, very careful with any change and build automated testing so that as the same with software, we can deploy to production and put to production agents with confidence.
Yeah, even more important than testing software, probably.
Yeah,
definitely.
At least the software is deterministic.
Exactly.
Even the same version of the same, a new version of the same foundation model can change the behavior of your application, and without an evaluation benchmark suite, you will not notice the regression.
Yeah. Okay, thank you so much. I think we touched so many topics, from agent definition, how the data architecture should support agentic AI, and how to implement, what is the software architecture of an agentic system, which are the the biggest benefits for the business, and also the biggest problems that business can face in deploying such architecture. Thank you so much. Thank you so much for participating in this episode. So please remember to subscribe on our channels. It's very important for us. And see you the next episode. Bye. Bye. Bye.
Bye.